All right, well, welcome to the last lesson for Chapter 6. I've got my old friend Ben back helping me, and tonight's lesson, he invariably picks problem-solving lessons to come do. And problem-solving lessons are a little hard to record flip videos for because, the problem-solving strategies, when we're doing problem-solving questions tomorrow, pretty much you can use anything you've learned so far. So anything you learned back last year in Course 1, anything that we've talked about this year is fair game, but each section, each chapter, we do introduce a new technique or a new strategy that you use. And so tomorrow is going to be one of those lessons where you pick so many problems, and there's going to be A, B, and C problems, and you're going to have 4 A problems that are going to lend themselves to the strategy that we're talking about today. So let's get right to that strategy. So today's strategy is to make a table, and what we're going to do is we're going to walk you through an example in the book. All right, so here's the example that kind of motivates this lesson to kind of show you how using a table can be really handy. So let's all read this together quickly. Suppose we knew that the population at the beginning of the year 2000 of the United States was 273.5 million people. All right, and we know that there was a steady population increase of 0.85% per year, just a little less than 1%. Okay, if that rate continues steadily, and that word really should be in here right now. Right here we should have the word steadily. What will be the population at the beginning of 2010? Now this book was actually written a little while ago, so it was written between 2000 and 2010, so we can actually do this problem and go back and check census data for 2010 and see how accurate this prediction was and see if that 0.85% rate of increase did carry on. So as always, Ben, what's the very first thing you're supposed to do with every problem-solving lesson before you even decide how you're going to solve it? Read it. How?
Reduce it.
Reduce it. Listen to you. Read it carefully and make sure you understand what's going on. Okay? How many times should you read it before you start working the problem?
Probably 3 times.
Well, 3 would be fine. At least twice. When's the third time you're supposed to read it?
To go back.
Yeah. At the end, go back and read it a third time and make sure that what you did answers the question that was asked. All right, so what information are we asked to find? This is pretty easy, right? They're asking us to find the population basically after 10 years. Now, there is a way later on in Algebra 1 or Algebra 2, depending on what curriculum you're using. There is a way to solve this problem with a single equation, but it involves an exponential growth function. That's not really the way we're going to do it in pre-algebra. So what we're going to do is we're going to make a big table, and we're going to do 1 year at a time, and we're going to find the growth, and we're going to add it in. Then we're going to find the growth from that year. So we'll find how much it grows in 2000, we'll add it in, we'll find the new population. Then we'll do the growth again, we'll find how much it grows, and we'll add it in, and we'll just do that 10 times. And what we're going to do is we're going to organize it, and at the end of 10 steps of that, we should have the population in 2010. All right, so let's go ahead and skip right ahead into that. So here in the book, again, you can follow right along in your book. They've already started this chart for us, and so there's the first several steps. And you can see that the first column is the population where we are right now. You notice that in the second column, all the way through here, it's always a growth rate of 0.85%, which as a decimal is 0.0085. And I want you to notice something else here. You can't just do this one time and assume that we're always going up by the same amount. So initially when I do 8.85% of the population, I'm only getting about 2.3 million new people a year. But as the population gets bigger, since you're taking a percent of a bigger number, it goes up to 2.4 million. It's probably going to go up again to maybe 2.5 million. It might even go up to 2.6 million. Yeah. All right. So we're going to actually have to figure that part out in order to fill out this chart. All right. So let's go ahead and let's assume that all of these other steps have done. So notice what they've done. They did 0.0085 times 273.5, and they produced, rounded to the nearest tenth of a million. They got 2.3 million people, and they added it in. That's where they got this. Okay? And that was a little bit too dark. Okay? So now the next line, they take where they finished, and they brought it back over here, and they do it again. This time, again, they got 2.3. They added in. They get 278.1. All right, and as you can see, basically each line, wherever they end up in the line, that's where we start the next line, okay? All right, so let's pick up, Ben, where they left off. All right, so right here, we're in year 2007, and they've got 290.1 million, all right? So we're going to take 290.1, and we're going to multiply by 0.0085, and we're going to find out how much we increase by. Now, this one comes out to be what?
2 and 46.
2.46. So if I'm going to continue to round to the nearest 10, that one's actually going to jump up now to 2.5. Sorry, it's a little hard to see, though. Let me squeeze it in there. All right, so now we add 2.5. We'll add 2.5 to 290.1, and now we're up to 292.6. So that's the population in 2008. Again, multiplied by 0.0085 for the 8.85% increase. This time we again get 2.48, which is again going around to 2.5. Okay, and we can continue doing this all the way until we get to 2010. Okay, if we continue to do this, the next 3 additions are all going to be 2.5, okay? And you can try this on your calculator. Now, I could actually do this without rounding, too, and I'd get an even more accurate answer. But at the end of all this, let's go ahead and put the answer in here. We're going to end up with 297.6 million people, okay? And that is actually whoops. That didn't quite fit in there. All right, well, that's million. We'll put it down there. All right, so that's the idea. Now, to try to solve this problem just on a calculator, just in our heads, or in one step would pretty much be impossible. And there's going to be a lot of different phenomena like this. It could be a bank account where you're putting money in every month, and so what you're going to do is you're going to take your balance, you're going to put the money in, figure out what you've got, and then the next month put more money in. And so there's a lot of different problems like this that if we're just very systematic, we can go ahead and we can solve them. Okay, a good example of a job that would entail this type of thinking would be an accountant, where you keep tables of books and you keep records of expenses and income, and you organize it in a big table, and you go ahead and do it. Also, we can do this on a computer. There's no reason to do all this by hand. So we could set up an Excel spreadsheet and very quickly do the same thing. We could even set it up to do it automatically. All right, so that's the idea, guys. That's the new problem-solving strategy. So in addition to all the other stuff we've learned about reading questions carefully, okay, twice before you get started, once when you're done. And then all of the other strategies like try, test, and revise, draw diagrams, solve simpler problems. All of those are going to be fair game for the latter half of this lesson. All right, so moving ahead, there is my trusty helper, Ben, saying that's all, folks.
Is that a beautiful picture?
What is up with the beautiful pictures? Gosh. All right, anyway, so looks like you're like you just got called on and you don't know the answer to the question. In any case, thanks for watching our video, guys, and tomorrow in class we'll be practicing the problem solving. Okay, that's it for tonight. Bye.